Very good afternoon, students. I hope all are doing good. Stay safe, healthy, at home always. Because the situation is going very bad. Don't go outside of your house unnecessarily. So, we have been discussing this lesson in the last classes basic concepts of chemistry and chemical calculations. So, this lesson we are about to finish this lesson by next class. So in the last class we discussed about the stoichiometry calculations and limiting reagents. Do you all remember the calculation, how to calculate the limiting reagent and what is stoichiometry calculation, all that we discussed in the last class. Today we are going to see the redox reactions. So you all know very well what our redox reaction means. So when oxidation and reduction takes place simultaneously, we call it as an redox reaction. So same way we have so many types, like how we are having different types of chemical reactions. This redox reaction also has been classified into different types that we are going to see in detail today. What are redox reaction, how to calculate the oxidation number. When it comes to redox, it involves oxidation. So oxidation means we have to know how to calculate the oxidation state, oxidation number, all that. So we will see that also. Along with that, we will see the classification of this redox reaction and rules for identifying the oxidation number. So if you see this apple, you can imagine this picture. When an apple is cut and kept outside for a longer period of time in the atmosphere, you can see this condition. Yes or no? When an apple is cut and kept open in the atmosphere, what will happen? The layer of the apple will change into brownish in color. So why it is happening? It is because of the redox reaction only. When an apple is cut, it is changing into brown after some time. Do you know the reason behind this color change? It is because the chemical reaction called oxidation takes place. So how does a fuel is burning? How this what is this cylinder or cylinder, what is cylinder gas made up of? It is mostly propane and butane. It is composed of the cylinder. LPG is propane and butane. So how it is burning suddenly? So those gases will react with the oxygen, that is combustion reaction takes place with the oxygen. So that is how it is burning. That is also an oxidation. Oxidation means what? Addition of oxygen, we call it as an oxidation. Removal of hydrogen also we call it as oxidation. Loss of electron also we call it as oxidation only. Same way, if you see any iron material, it is kept open in the atmosphere, it will start to rust. It is also because of oxidation only. So we come across oxidation reactions in our daily life. For example, burning of LPG gas, rusting of iron, and oxidation of carbohydrates, lipids into carbon dioxide and water to produce energy in the living organism. All oxidation reactions are accompanied by reduction reactions and vice versa. So எல்லா oxidation reactions எப்படி reduction reactions ஆலையும் இருக்கும். இல்லை எல்லா reduction reaction it is accompanied by oxidation reaction. So such type of reactions, when both are involved together, it is both on oxidation and reduction are involved together, we call it as an redox reaction. So as per the classical concept, addition of oxygen or removal of hydrogen. So this you would have studied in your 9th and 10th standard itself. Addition of oxygen and removal of hydrogen, we call it as oxidation, and the reverse is called reduction. So if you see this reaction 1, iron reacts with oxygen to give iron oxide. So here we are adding oxygen to iron. So this is oxidation. So H2S is hydrogen sulphide reacts with the chlorine to give hydrochloric acid and sulfur. So we are removing the hydrogen from hydrogen sulphide. So removal of hydrogen is also oxidation. So both these reactions are redox reactions as per the chemical classical concept. Why? Because here we are adding oxygen to this, here we are removing the oxygen. Same way, here we are removing the hydrogen, here we are adding the hydrogen. So this is a redox reaction. In the first reaction, which is responsible for the rusting of iron, the oxygen adds on to the metal iron. In the second reaction, hydrogen is removed from hydrogen sulphide. Identify which species get reduced. So consider the following two reactions in which the removal of oxygen and hydrogen take place respectively. So these reactions are called as redox reaction. So here if you see in these reactions, only oxygen is adding here, here only hydrogen is removed. So this is oxidation, this is reduction, but both taking place at a time. So here CuO and C, what is happening? From CuO, oxygen is getting removed and oxygen is adding here. So here it is removal of oxygen, here it is addition of oxygen. So removal of oxygen means it is reduction, addition of oxygen. To copper, what is happening to copper? It is reduction, removal of oxygen. We are removing oxygen from here, it is reduction. Here we are adding oxygen, this oxygen is getting added to this carbon, it is what? Oxidation. So removal of oxygen from cupric oxide. Same way, we are adding hydrogen to this sulfur, and one hydrogen is both the hydrogen they are adding to the sulfur. So addition of hydrogen. So this is reduction. Oxidation reduction reaction, that is redox reactions, are not always associated with oxygen or hydrogen. In such cases, the process can be explained on the basis of electrons. That is what I told. Removal of electrons or loss of electrons also is called as oxidation. Gain of electron is also called as reduction. So always we can't expect addition of oxygen means it is oxygen. Addition of hydrogen means it is reduction. We can't talk always in the terms of hydrogen and oxygen. We can also explain this in the terms of addition or removal of electrons. If removal of electron means it is oxidation. If electrons are added means they are reduction. The reaction involving the loss of electron or removal of electron is termed as oxidation, and gain of electron is termed as reduction. Very important. So if you see here, Fe2 plus, already iron is lacking 2 electrons, that is why we have written Fe2 plus, yes or no? So here I am going to remove one more electron from iron, so that it is going to what? It is going to lose one more electron along with this 2 plus. So it will become Fe3 plus and one more electron. That one electron is removed. So loss of electron means it is oxidation. So here in Cu2 plus, copper is lacking 2 electrons. I am adding 2 electrons here so that this will become to the zero state. So copper, here we are adding 2 electrons, which means gain of electrons, it is reduction. So redox reactions can be better explained using the oxidation number. So let us see what is meant by oxidation number. It is defined as an imaginary charge left on the atom when all other atoms of the compound have been removed in their usual oxidation states that are assigned according to the set of rules. So it means it is defined as an imaginary charge. It is not a permanent charge. It is an imaginary charge left on the atom when all the other atoms of the compound have been removed in their usual oxidation state. If any of the atom it is removed, then we will give an imaginary charge. That number we call it as an oxidation number. A term that is used often interchangeably, oxidation number is oxidation state. It is actually oxidation number only. We can use, people have started using oxidation state. So the oxidation state of a free element. So these are the rules. It is very important 5-mark question. The oxidation state of free element. For free element, for copper or iron or silver or gold, the oxidation state is, that is a free element. Okay, it is in the uncombined state, free state. It is the 0. For oxidations, the oxidation state for free element, it is always 0. For example, each hydrogen atom, chlorine, sodium, sulfur have the oxidation number 0. Second point, for a monoatomic ion, the oxidation state is equal to the net charge on the ion. So for monoatomic ion, the oxidation state, monoatomic ion means what? Na plus, Cl minus, ஒரு electron lack ஆயிருக்கும், இல்ல ஒரு electron excess ஆயிருக்கும். That is anion or cation. Monoatomic anions or cations, the oxidation state is equal to the net charge, which means if Na plus means it is 1 plus, which means it is lacking 1 electron. So the oxidation number of the sodium also will be plus 1. So here in Cl minus, it is Cl minus means minus represents excess of electrons, which means 1 electron is excess in chlorine. So the oxidation number of chlorine will be minus 1. So excess means we will give it as minus here. Is it clear? It is not like mathematics. If the electrons are lesser, we will put plus. If the electrons are more, we will use negative symbol. The algebraic sum of oxidation state of all atoms in a molecule is equal to 0, while in ions it is equal to the net charge of the ions. The algebraic sum of oxidation states of all the atoms. So ஒரு காம்பவுண்ட் எடுத்துக்கிட்டோம் அப்படின்னா அதில் இருக்கிற நம்ம ஆக்சிடேஷன் நம்பரை ஆட் பண்ணி பார்த்தோம்னா இட் ஷுட் பி ஈக்குவல் டு 0. ஃபார் எக்ஸாம்பிள் NaCl எடுத்துக்கிட்டிங்கன்னா Na plus Cl minus. ஸோ இஃப் யூ see here, NaCl minus. So Na plus it is there, Cl minus na idu ionize agum. So idoda charge, idoda oxidation number +1, Cl oda oxidation number -1. Idu renduthiyum namba algebraic sum eduthona it is 0. So algebraic sum of the oxidation state of all the atoms in a molecule is equal to 0, while in ions it is equal to the net charge on the ion. Ion thaniya pirichu paakumbodhu it is the net charge of that particular ion. Altogether if you see, it should be 0. So for example, H2SO4, if you see here, H2SO4 ku 2 into oxidation number of hydrogen is, it is 1, and for oxidation number of sulfur is, it is 6, and oxidation number of oxygen is -2. If you do the answer and if you get the answer will be 0. Same way SO4 2 minus ku இப்படி மேலே charge இருந்துச்சுன்னா you have to take it equal to க்கு right hand side you have to put it as -2. So oxidation number of sulfur is 6 plus oxidation number of oxygen, so 6 minus 8 is equal to -2. So 6 minus 8 na enna varum? Always remember, oxidation number of hydrogen is 1, for sulfur it is 6. So here SO4 2 minus nirkilla, for oxidation only one sulfur is there, so 6 plus for oxygen 4 oxygen are there. Oxygen oda value it is -2 is equal to charge -2 irukla, that should be put on the right hand side. So 6 minus 8 is equal to -2, minus 2 is equal to -2. Then if you bring that inside, -2 plus 2 is equal to 0. So you will get the answer as 0. So hydrogen has the oxidation number +1 in it all compounds except in its metal hydrides where it has -1 value. Hydrogen oda oxidation number +1 da, but hydrides, metal hydrides are, for example sodium hydride NaH, lithium hydride LiH, இத மாதிரி பாக்கும்போது இது ஹைட்ரஜனோட ஆக்சிடேஷன் ஸ்டேட் அங்க என்னவா இருக்கும், -1 ஆ இருக்கும், or otherwise மற்ற இடத்துல எல்லாத்துலயுமே +1 ஆ தான் இருக்கும். ஸோ HCl ல பாத்தீங்கன்னா இதோட ஆக்சிடேஷன் ஸ்டேட் +1, NaH ல எடுத்தீங்கன்னா ஹைட்ரஜனோட ஆக்சிடேஷன் ஸ்டேட் -1, and fluorine has an oxidation state of -1 in all its compounds. ஸோ fluorine எங்கே வந்தாலுமே அதோடைய ஆக்சிடேஷன் ஸ்டேட் என்னது, -1 தான். The oxidation state of oxygen in most compound is -2. Oxygenோடைய oxidation number என்ன, just now I told it is -2, but it changes when it comes to peroxide, superoxides and compounds with fluorine. So here in water lo oxidation state of hydrogen is -2, then hydrogen peroxide it is -1. You have to calculate, you have to see how to calculate. So how to calculate the oxidation number? So what is known already, you have to keep it as it is. So for example, you want to calculate the hydrogen state of oxygen in hydrogen H2O2. So that should be taken as X. So now 2 into H ன்னு இருக்குல்ல, so H ஓட வேல்யூ நமக்கு தெரியும் 1. Okay, so 2 into 1 plus 2 oxygen are there, but I don't know the value of oxygen. You have to take it as X is equal to, இங்க -2 போடக்கூடாது because இங்க peroxidesக்கு change ஆகும்னு சொல்லியிருக்கிறாங்க, is equal to 0. So 2 minus 2x, that is 2 is equal to -2x, and x is equal to -2 by 2, which is -1. So oxygen normally எழுதும்போது it is -2 oxidation number. When it is coming in form of peroxide, the answer is -1, which means the oxidation number of oxygen in peroxide it is -1. Same way in superoxide it is -1/2, and then in oxygen difluoride, just now they told oxidation state of fluoride oxides, fluorooxides it is +2. Fluoride la varumbodhu it is +2, OF2 ன்னு வரும்போது it is +2, and this is superoxide which is -1/2. hydrogen peroxide la வரும்போது it is -1. normal oxygen water la பாத்தீங்கன்னா it is -2. you can calculate and check that. alkali metals have the oxidation state +1. alkali metals na enadhu group 1 elements, அதோட oxidation state +1. group 2 elements or alkaline earth metals, their oxidation state is plus 2. So few calculations are given here. So in the compound la oxidation number of the element carbon oda oxidation number in carbon dioxide கேக்குறாங்க. So carbon தெரியல, கார்பனுக்கு தெரியாதுன்றதுனால you have to take that as x ன்னு எடுத்துக்கணும். and oxygenக்கு நமக்கு தெரியும் -2 ன்னு, ரெண்டு oxygen இருக்கு. so 2 into -2 ன்னு எடுத்துக்கணும், and then is equal to 0. and if you substitute and get the value, you will get the answer as +4. so the oxidation number of carbon and carbon dioxide is +4. same way for sulfur in H2SO4. so sulfurக்கு நமக்கு தெரியாது, ஹைட்ரஜனுக்கும் ஆக்சிஜனுக்கும் தெரியும். அந்த வேல்யூவை சப்ஸ்டியூட் பண்ணிட்டு சல்ஃபர் இருக்கு நம்ம x ன்னு சப்ஸ்டியூட் பண்ணி ஐடென்டிஃபை பண்ணணும். சேம் வே ஃபார் Cr in Cr2O7 2-, இப்படி மேலே சார்ஜ் 2- ன்னு வந்ததுன்னா ரைட் ஹேண்ட் சைடில் அந்த சார்ஜ் நம்ம சப்ஸ்டியூட் பண்ணிக்கணும். இங்கெல்லாம் பார்த்தீங்கன்னா கார்பன் டை ஆக்சைடு சல்ஃபியூரிக் ஆசிட்க்கு எந்த வேல்யூவும் இல்லை. ஸோ யூ ஆர் டேக்கிங் இட் as 0. ஸோ ஹியர் இங்கே சார்ஜ் இருக்கிறதுனால யூ ஹவ் டு டேக் இட் as -2. and Cr2 ரெண்டு Cr2 இருக்குன்னா நமக்கு Cr2க்கு தெரியலை. ஸோ யூ ஹவ் டு டேக் இட் as 2x. then CH2F2 you have to calculate SO2. so see this calculation, this will be asked in 1 mark and 2 mark question. and redox reaction in terms of oxidation number. so what is the redox reaction in terms of oxidation number? so during redox reactions the oxidation number of element changes. so என்ன ஆகும், oxidation number சேஞ்ச் ஆகும். கண்டிப்பாக ஒரு ரிடாக்ஸ் ரியாக்ஷன் நடக்கும்போது, பிகாஸ் எலக்ட்ரான் ட்ரான்ஸ்ஃபர் இல்லைங்களோ, எலக்ட்ரான்ஸை பொறுத்து தான் நம்மளுடைய ஆக்சிடேஷன் நம்பரும் இருக்குது. ஸோ ரிடாக்ஸ் ரியாக்ஷன் நடக்கும்போது ஆக்சிடேஷன் நம்பர் சேஞ்ச் ஆகும். ரியாக்ஷன் இன் விச் ஆக்சிடேஷன் நம்பர் ஆஃப் தி எலிமெண்ட் இன்க்ரீசஸ். ஆக்சிடேஷன் நம்பர் இன்க்ரீஸ் ஆச்சுன்னா தட் இஸ் ஆக்சிடேஷன். in which oxidation number decreases, then that reaction is reduction. so oxidation number மாறும்போது we are defining that as oxidation and reduction. ஸோ எப்படி டிஃபைன் பண்ணணும், ஒரு ரிடாக்ஸ் ரியாக்ஷனில் ஒரு பர்டிகுலர் ஆட்டம், ஒரு காம்பவுண்டில் ஒரு பர்டிகுலர் ஆட்டமில் ஆக்சிடேஷன் நம்பர் இன்க்ரீஸ் ஆச்சுன்னா இட் இஸ் ஆக்சிடேஷன், டிக்ரீஸ் ஆச்சுன்னா இட் இஸ் ரிடக்ஷன். ஸோ இங்கே பார்த்தீங்கன்னா மேங்கனீஸ் இருக்குது ரியாக்டண்ட்டில், அது ப்ராடக்டில் இப்படி +2 மாறி இருக்குது. மேங்கனீஸோட ஆக்சிடேஷன் ஸ்டேட்டஸ் +7, பட் இங்கே +2 கன்வெர்ட் ஆகிருக்கு. ஸோ +7லேருந்து +2க்கு டிக்ரீஸ் ஆகிருக்கு. ஸோ அப்போ இங்கே என்ன நடந்திருக்கு, மேங்கனீஸ்க்கு பொட்டாசியம் பெர்மேங்கனேட்டில் ரிடக்ஷன் நடந்திருக்கு. அயன் இருக்குது, இங்கே அயனில் +2 ஆக்சிடேஷன் ஸ்டேட்லேருந்து +3 ஆக்சிடேஷன் ஸ்டேட்டுக்கு இன்க்ரீஸ் ஆகிருக்கு. ஸோ இங்கே என்ன நடந்திருக்கு, ஆக்சிடேஷன் நடந்திருக்கு. ஸோ இன் திஸ் ரியாக்ஷனில் தட் இஸ் வாட் ஐ டோல்டு, manganese has got reduced, iron has got oxidized. such reagents are called oxidizing or oxidants. ஸோ எந்த ஒரு reagent, எந்த ஒரு compound or solution which makes this to happen, இதை சேஞ்ச் பண்ணுறது, இதை மாதிரி ரிமூவல் ஆஃப் கெயின் ஆஃப் எலக்ட்ரான் எதை பண்ண வைக்குதோ, எஸ்பெஷலி ஆக்சிடேஷன் நம்பர் இன்க்ரீஸ் பண்ண வச்சதுன்னா இட் இஸ் அன் ஆக்சிடைசிங் ஏஜென்ட் ஆர் ஆக்சிடென்ட். சேம் வே which makes the reduction possible, we call it as an reducing agents. Clear?